Okay. All right, so what we're going to do today is very similar to what we have been doing so far because we will be looking for relative minimums and maximums. So a relative maximum is a point at which the function f switches from increasing to decreasing. Right? Now, this is our definition of a maximum. So we might want to put definition of maximum. Cannot be used for justification. Okay, so this is the definition of a maximum, is where we switch from increasing to or relative maximum. We switch from increasing to decreasing. We cannot use that to prove that something has a relative maximum because it's just the definition. So if they say find the relative maximum and you tell me it's at 7 because the function switches from increasing to decreasing, you may have just gotten lucky. You may not understand because that, since it's a relative maximum, that has to be the definition, right? You would just be restating this and may or may not know what you're talking about there. So anything that we are asked about here, we have to prove using calculus. So they are not going to ask you just to restate a definition for them. You have to prove it using calculus. So if our function switches from increasing to decreasing, what is going to happen to the derivative? Positive to negative. Okay, this part, that's your justification. So whenever we do these, we always have to summarize at the end. If it's free response, we have to say that there is a relative maximum at x equals this because the function switches from positive, or the derivative switches from positive to negative. So you need to be talking about the derivative in your justification. Relative minimum, obviously, is very similar here. Right, what we've got right here is our definition. Okay, our definition about a relative minimum is that our original function is going to switch from decreasing to increasing. That's our definition. If our function switches from decreasing to increasing, what happens to the derivative? Nope. Decreasing would be negative, and increasing would be positive. This is your justification. Okay. Now, we're going to learn a second derivative test on later in this unit. Right now, this is the only one we've got. So this, if they ask us about a relative maximum or minimum, then we are going to use the first derivative test. So, the first derivative test just means we're looking for places where this function's derivative switches from increasing to decreasing or decreasing to increasing. So it's going to be a lot like what we were doing yesterday when they were just asking us for increasing or decreasing, right? So, for example, here is our first example. We need to know where this function is increasing and decreasing. This is the same as what you guys were doing yesterday. So, f prime of x for this would be 6x squared minus 30x plus 36. And you need to find critical points for this. So you are going to set this equal to 0. And I would either factor out or divide off a 6. You can divide it off if you want, then it'll just go away. So x squared minus 5x plus 6 equals 0. And we can factor that. So that'll be x minus 2 and x minus 3, I believe, which will give you x equals 2 and x equals 3. You cannot, because that will give you a -6 right there. So you cannot. But I will tell you that this right here is one of the most missed factoring problems in Math 1 because of exactly what you just tried to do, right? Yeah, kids miss it all the time because -6 and 1 seems like it should also work. But -6 and 1 would give you the -6 over here, so it would not. So 2 and 3 are critical points. Here is the way I would use a chart for this. So I would do x minus 2 and x minus 3. And actually, I divided off the 6. I really should have factored it out instead because if that was a -6, it affects your sign. If it's a +6, it doesn't because it's just positive. But let's factor that out instead of dividing it off. That would be better practice. Because if that number right there, if that number is a negative number, like if you're factoring out a -6, it does change the sign of everything. Since it's positive, it doesn't make any difference here. So we got 2, we got 3. Okay. 6 is always positive. If you don't include it in the chart, it's not a big deal. If it were -6, it would be a big deal that you included it. Here, for x minus 2, if I plug in something like 0, I'll get a negative. But then if I plug in anything bigger than 2, I'm going to get positives after that. If I plug in like 0 here, I'll get a negative. If I plug in something between 2 and 3, like 2.5, I'll still get a negative. But then anything bigger than 3 gives me a positive for that. We did. It's basically what we did for pre-cal, but we're looking at derivatives instead of looking at those inequalities that we were looking at. I'm going to look at my columns. If I have an even number, I get positive for my answer, negative here, and then positive here. So if we think about what this means for f of x, so let's write this down here. F of x here, below 2 is going to be increasing. Then, since our derivative is negative between 2 and 3, f of x will be decreasing, and then it will increase again. So, we have a change. We're increasing till here, where we switch to decreasing, till here, where we switch back to increasing. So, what are we going to have right here at x equals 2? We will have a relative maximum. And right here, we switch from decreasing to increasing, so we will have a relative minimum. And I need to go back and work on these notes. I'm going to say find all x coordinates. You can. So you can have an infinite number of relative maximums. For example, sine or cosine. They have an infinite number of maximums and minimums because it just goes over and over and over again. So it can happen that you have several maximums or minimums here. They are relative. For absolute, you would only have one y value, but you can still have that repeated. Like sine is going to have an absolute maximum of 1. It's just going to happen at a bunch of different places. So you can have more than one for this. Now, to conclude here, because if this is free response, you have to write a conclusion. You are going to say that f of x has a relative maximum at x equals 2 because f prime of x switches from positive to negative at this point. Okay. Be careful in writing your f prime. Make sure you can tell it's a prime. Make sure that you say at x equals 2. Make sure that I know in homework it's not the end of the world if you're like writing out just a negative sign and positive sign. I would not do that on anything you're turning in because it is easy for those signs to get lost or misinterpreted as a part of a word or something. Whereas if you write out the word positive, it's hard to misinterpret that. So I would write it out. Probably write out relative maximum too on like the real thing, but I'm pretty sure you're going to be okay on that. But you don't want to lose points just to save a little bit of time. So I would write them out there. Will they take it if it's very clearly stated with a plus and a minus there for your positive and negative? Probably, but you got so much more room for error. You also need to tell about your minimum. So f of x has a relative minimum at x equals 3 because f prime of x switches from negative to positive at this point. Okay, so this is what these should look like. It's very similar to what we were doing yesterday, right? Basically, the only difference in what we're doing today and what we were doing yesterday is that they're not asking for increasing, decreasing intervals. They're asking for relative maximum or minimum points. So your conclusions are different. You want to talk about the derivative switching signs at that point instead of saying the derivative is positive or negative. It is okay on this, like, because f prime switches from negative to positive, it means that f switches from decreasing to increasing. You can add that at the end if you want, but it is unnecessary. This is all you have to have. What you cannot have is saying f of x has a relative minimum at x equals 3 because f switches from decreasing to increasing, because that is just your definition. It is not your proof for that. So I'm going to have you guys do just a couple problems on this because we did not do many of these, and we're going to practice more. So let me look at the book here. Let's do page 233. Let's do 21. Let's do 25 and 27. Okay, so just those three that I want you to do for me there, 21, 25, and 27.